Hello. Today we will continue our mathematical background revision on vectors. Let me just remind you quickly what we did last Thursday. So I reminded you of Pythagoras theorem, which is in case of a right triangle, the hypotenuse square is equal to side 1 square plus side 2 square. Okay, so in this case, BC square, the hypotenuse, which is the side facing the right angle, it's equal to the square of the first side plus the square of the second side. I also reminded you of the sine of an angle, the cosine of an angle, the tangent of an angle. These, if you don't remember them, you just memorize them. The sine of an angle, let's take, for example, angle theta. The sine of it is the opposite side divided by the hypotenuse, So in this case, the sine of theta is AB divided by BC. So you just memorize this. The cosine of the angle is the adjacent side divided by the hypotenuse. The tangent of the angle is sine over cosine. So it's opposite over adjacent. You just memorize these. I think all of you have seen them at some point. You just have to remember them. Okay, now this is about trigonometry. Why did I refresh your memory about trigonometry? Because in this chapter, the vectors, that is the displacement, the velocity, the acceleration, they will not be only changing in one dimension. So far we have been dealing with situations where the displacement is horizontally or the displacement is free fall vertically, or the displacement is with a slope. Okay, so all this is motion in one dimension, but this chapter is motion in two dimensions. If I look at this angry bird over to reach this angry bird over here, I have to change the angle. See, I'm changing the angle of the velocity, and this velocity is changing not in a straight line, or the displacement is not changing in a straight line. Look at it, how the particle is moving from here to here. This is not, look at the blue line. This is not a straight line. This is something changing in two dimensions. It's going, while the particle is moving, it's going left and right. Actually, in this case, it's going more, it's changing in two dimensions, okay? So because now I'm dealing with vectors that are the displacement, velocity, and acceleration are moving in two dimensions, that's why we remember this trigonometry. Okay, let's see how we will apply this. So any quantity that it changes direction, we call it a vector quantity, okay? Displacement, for example, it's a vector quantity because you say I moved from left to right, or I went from Saida to Beirut, or from Sur to Saida. So you are specifying the direction, okay? The velocity goes alongside the displacement, and acceleration, we decided it depends if it's the velocity is increasing or decreasing, or it's going up or going down. So also the acceleration is a vector quantity. What are quantities that are not vector quantities? Temperature, for example. When we say the temperature today is 34, okay, is this a vector quantity? No, this is just a scalar quantity. I use a thermometer and it gives me exactly the temperature. Another quantity which is not a vector quantity, it's the mass of an object, okay? You buy 500 grams of cheese, that's 500 grams of cheese. This is the mass of the cheese. This is not a vector quantity. It will not change if I move from my home to Saida. If I go from Saida to Sur carrying 500 grams of cheese, it will be 500 grams of cheese. That's a scalar quantity, okay? Another scalar quantity is the distance. That is, in our car, there is this speedometer that measures how many kilometers I go. It doesn't matter if I go from Saida to Beirut, to Tripoli, back to Saida, it will measure the whole distance. That is the distance, okay? However, if I want to say what is the displacement, if I go from Sur to Saida to Beirut, back to Saida, the displacement will be only from Sur to Saida, okay? So remember, displacement is a vector, distance is a scalar. Okay. Likewise, velocity is a vector, speed is a scalar, temperature is a scalar, mass is a scalar. Another quantity which is a vector, and it's very important, forces, for example. Forces, if I push you, if I punch, let's say there is a door, okay, which only opens if I push it. So if I pull it, it will not open. So if I apply exactly the same force, but I'm pulling it, it will not open. I have to push it. These things you find in malls. You will find a door of the shop and it says push. So no matter how strong you pull, you are exerting force, but it's in the opposite direction, it will not open. However, just give it a slight push, it will open. So forces are also vector quantities. Okay. So vectors are so important, and especially for our lesson over here, because now we are motion in 2 dimensions, we will be focusing on displacement, velocity, acceleration, how to measure how to represent them as vectors. Okay. So let's take any vector f. Let's take any vector f. It's here in blue. This vector has 2 components. So we say each vector has 2 components. Sorry, not quantities. It has 2 components. Okay. It has an x component. It has an x component, which is along the x-axis. And it has a y component, which is along the y-axis. How to draw the x component? Okay, so the blue line is my f vector. To measure the x component, I just start from the f, from the origin of f, and I walk on the x-axis. I walk on the x-axis. I walk on the x-axis until I reach the tip of vector f. Then I start moving in the direction of the y-axis. The y-axis is upward, so I start walking on the y-axis, 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 until I reach the tip of vector f. Okay, so this is how I draw the x and the y components. So we say each vector is in 2 dimensions, has two components, x component and y component. How do I draw the x component? I go on the x-axis until I reach the tip of vector f. Then I go along the y-axis until I reach the tip of vector f. Notice here I must have a 90-degree between the x and the y component, just like I have 90-degree between the x-axis and the y-axis. Now, what did I learn about trigonometry? I learned that if I have a hypotenuse and I have 2 sides and an angle, I learned that fx, let's say this, I learned that cosine of this angle theta, okay, this is a theta, it's equal to adjacent side divided by hypotenuse, right? Let's give it some abbreviations here. So how much is cosine theta? This will be the adjacent side, which is fx, divided by the hypotenuse, which is f. So this is cosine theta. Implies, what will this give me? Implies how much is fx? I do cross multiplication. It will be f times cosine angle theta. Okay, so it will be f times cosine angle theta. So it's written over here. I do the same thing for the sine theta. Sine theta will be opposite side divided by hypotenuse. Opposite side is fy. So fy will be f sine theta. And this is what I get. Fx will be f cosine theta. Fy will be f sine theta. Let's take examples to see how do I apply these immediately. So let's take examples. Determine the components. So we call them components, okay? Determine the components of each of the following vectors. I have this vector A. It is 5, making an angle theta equal to 30. Okay, so I need to find AX and AY. I can directly apply AX equal. I don't have to go through this, but you can do it if you like. So cosine angle 30 is AX divided by A. So AX is A cosine 30. A is 5 cosine 30. I get AX. I do the same for the sine. It's opposite divided by hypotenuse. So AY will be 2.5. So vector A, and this is how I represent it. Vector A will be the X component 4.33, comma, Y component 2.5. This is how I represent a vector in 2 dimensions. In 1 dimension, it was enough to say plus, minus. We were saying the displacement is plus 10. The acceleration is minus 9.8. That is in 1 dimension, plus, minus, because it's only 1 axis. Now we have 2 axes. So I have X component and Y component. So this is AX and this is AY. Okay. This is vector A. Let's take another example. I have vector B. It's 5 also, but it is like this. How much is the angle? Notice here that the angle is the angle that A makes with the x-axis. Okay, the theta is the angle that the vector makes with the x-axis. I forgot to mention it here. So let's come back here. I have vector B. It is 5. What is the angle that vector B is making with the x-axis? What is the angle? Angle theta equal how much? It is along the x-axis, so angle theta equal to 0 because it is along the x-axis. Okay, let's look at it. So in order to go to Bx, we move along B until we reach the tip. So Bx is 5. Then we go along the y-axis, but there is nothing along the y-axis. So By is 0. Okay. So what is vector B? It is 5, 0. As simple as this. Again, this is vector C. It's 5, making angle 40 with the x-axis. So the angle, let's put it here, angle theta equal, this is below the x-axis, so this we say it is minus 40. Okay, minus 40 degrees. You can actually say it is 40. That's not a problem. But then we have to pay attention. So let's say theta equal 40. Then we just have to pay attention to plus and minus. So this is vector C. This is vector C. And this is the CX and the CY. So again, CX is, you can directly say CX is C cosine the angle, and CY is C sine the angle. Okay. C is 5, the angle is 40, C is 5, the angle is 40. I do the calculation on the calculator. Then I come to vector C. You come to vector C, and here you just have to pay attention that CX is along the x-axis, so it's positive. CX is positive. Let's see if I can draw positive here. Okay, no. So CX is positive because it's with the positive x-axis. However, CY, it's downward, so it is negative. So I come here and I say CX is a 3.83. However, CY is minus 3.21 because it is going downward. Let's take another example. vector D, 5 as well. dx, it is how much I go along the x-axis. How much do I go along the x-axis in order to reach the tip of vector D? It is 0. It is 0. It's all of it is on the y-axis. So dx is 0. And how long I go along the y-axis? I go 5, but it's in the negative direction. So it is minus 5. So vector D here, it is 0, minus 5. Okay, as simple as this. This we did already. Okay, let's do one exercise from your booklet. Find the x and y components of the acceleration vector A shown in the figure below. So I have this acceleration vector. I have that it is 6 meters per second squared. It's making angle 30 degrees. I need to get AX and AY. Okay. So in order to get them, first I draw them. I go along the x-axis until I reach the tip. Then I go along, let's make it in another color. Then I go along the y-axis until I reach the tip. Okay, so this is here AX and this is here AY. So AX is A cosine theta, but because it's in the negative x-axis, it's minus. AY is A sine theta, but because it's in the negative direction, it is minus. So I get acceleration vector is minus 5.2 minus 3 meter per second squared. This is acceleration, so this is meter per second squared, the unit. Okay, so you can just memorize it. For any vector f, fx is f cosine theta. For any vector fy is f sine theta. And you just have to pay attention to if it's going along the x-axis, it's positive, opposite direction negative, positive y-axis positive, opposite negative. Now, magnitude and direction of any vector. If I have the same vector f and I have the fx and I have the fy, so far I had f and theta and my unknowns were fx and fy. Now, what if I have fx and fy and I want to calculate the magnitude of the vector f and the direction of angle of vector f? The magnitude of vector f is how long is vector f. Here I have to remember Pythagoras theorem. Pythagoras theorem. F squared is fx squared plus fy squared. So f is the square root of fx squared plus fy squared. This is the magnitude. And to get the direction, it's angle theta. I have to remember that tangent theta is opposite over adjacent. So theta will be tan inverse on the calculator. This is shift tan. Okay. On the calculator, you just do shift tan. Okay. Of this number, which is fy over fx, and I get the direction. Let's do a quick example. Example vector D. The x component is 3. The y component is 4. Find the magnitude and direction of vector D. I directly apply the formula. Vector D is the square root of dx squared plus dy squared. So it's the square root of 3 squared 9 plus 4 squared 16. So D is a square root of 25, and that is 5. Tan theta is dy over dx, implies theta is shift tan dy over dx. It is shift tan, dy is 4 over 3. You just use the calculator and you get theta equal 53.1 degrees. Okay. Now, addition of vectors. If I have two vectors, for example, let's say vector A in blue and vector B in blue, how do I add them? I just do it, one way is to do it graphically. I go from the origin along A, Then I shift direction to become like the direction of B, and I go until I go all the length of B. And then I just combine the starting point and the ending point, and this will be A plus B. So this is how I do it graphically. This is how I do it graphically. Another way to do it is algebraically, which might be easier. So if you are given two vectors, vector A, it has two components, AX, AY. Vector B, it has two components, BX, BY. Vector C, which is CX, CY, will be, let's say C is A plus B. CX will be AX plus BX, and CX will be AX plus BX, and CY will be AY plus BY. That's it. Let's do an exercise on this. Suppose vector C equal A plus B, where vector A has component AX equal 5, AY equal 2, and vector B has components BX equal minus 3, BY equal minus 5. What are the X and Y components of vector C? So you say CX is AX plus BX, that is 5 minus 3 equal 2. CY is AY plus BY, that is 2 minus 5 equal minus 3. So vector C is 2 minus 3. Determine the magnitude and the direction of vector C. You just remember the formula. The magnitude C is square root CX squared plus CY squared. So it's 4 squared. So it's, 4 plus 9. So it's square root of 13. That's 3.6. That's the magnitude of vector C. The direction theta is tan inverse of CY over CX. CY is minus 3 over 2. So the angle is minus 56.3 degrees. Okay, so this is just some revision on vectors. So we covered trigonometry. We covered how we calculate components of a vector, how we get the magnitude and direction of a vector, and finally, how to add vectors. Tomorrow, we will do more exercises on this, so as the idea will be clearer. Okay, bye-bye for today.